It's very nice to be here. Thank you to all of you for joining, and thank you to the organizer for inviting me. I'm Italian. I used to live in Germany. I studied, I did my in Karlsruhe, where I studied at the technical university, and later during my PhD, I spent another 6 months in Munich, where I was working at Fortis, an institute of the Technical University of Munich. Unfortunately, I didn't manage to learn German. I still hope that one day I will manage, but for now, I think I'm stuck with English. Today, I want to present this Jvm Interpreter that is written in Kotlin, which is open source, so you can just go on GitHub and download it, use it, and also look at the code. And we will explain what is RPG, this old programming language, and why we wanted to create this interpreter. Now, I'm the founder at Strumenta, but this presentation is not being created just by me, but also by people at SMEAP. So you may wonder, who is SMEAP? SMEAP is an Italian company with over 400 employees. They build an ERP. They have thousands of clients, including very large multinationals. They have sponsored the initial design of Jariko, and since then we have worked as partners to keep improving Jariko. So I would like to thank in particular Franco Lombardo and the SMEAP Lab, which is the R&D laboratory at SMEAP, for their help. Now, let's jump into the problem. What is the problem we are trying to solve? The problem is that SMEAP has this large application, this ERP, and they also have thousands of customization to fit the workflows of all their clients. And considering the core and this large amount of customization, they have a very large and valuable system written in RPG, which is this old language. And this situation is not ideal. So what is RPG? RPG is, in a sense, an high-level programming language that was created to write business application that's been created by IBM in 1959. So it has proven technology, we can say that. However, it's not exactly the most modern of languages. And until very recently, it was a fixed form language. The latest version is not fixed form, but in practice, the vast majority of code written in RPG is written in a fixed format. And let's see what it means to write code in a fixed format. It means that the compiler is simply expecting certain elements to be present at certain columns. So this piece of code that contains some data definition in RPG is not laid out in this way to make it more readable. It is laid out like this because this is strictly enforced by the compiler. For example, we can see that there is a letter D at column 7 of all these lines because it's required by the compiler to understand that these are data specifications. Now, in this case, I'm declaring 3 data structure, a data structure named customer info, which contains 2 fields, a name, which is a string of up to 20 characters, and an address, which is a string of up to 50 characters. Then I have a product info that contains a number and a description, both strings, and then it contains a cost, which is instead a number of 9 digits, 2 of which are decimal digits. So in essence, I can write a price with cents. Then we have a sales transaction, which has as the first field the buyer of type customer info, the seller of type customer info again, number of products, which is an integer, and products, which is an array of product info. I can also write code, so statements that my programs need to execute, and RPG is maybe not great for that. In this piece of code, we can see typical instruction like the eval instruction that is used to perform assignments. Then we have an if and an else clause, 2 lines below. And you can notice a first problem that we have with fixed form languages, because typically in more modern languages like Java, C#, and so on, we are used that when we have multiple if or while or other constructs, we can annotate them so that it's easy to understand, for example, that an else is connected to a certain if. In RPG, you cannot do that. So sometimes developer instead add a comment at the beginning of the line, because the first 6 characters of each columns are basically a comment. They're ignored by the program. So in this case, you can see that the author of this code wrote 5 on the line containing the if and the else. So you need to use this trick to make the code more readable. In this code, there is also one statement that will be important for what we will see later, which is the call statement. You can see that basically we are calling another RPG program called jd_URL, passing some parameters, and we will take advantage of this mechanism. Okay, now we have seen RPG, and let's now discuss what is the problem with RPG. It's not just the syntax. It's also the fact that RPG right now runs only on the IBM I system. IBM I is the new name of the AS400 platform. This is a platform built by IBM, but we really are strongly connected to the destiny of this platform. If tomorrow IBM decide that it's not convenient for them to sell these machines, well, we're basically stuck. And so, given that the RPG code is vital for many organizations, in this case we are talking about SMAP, but this is true for many organizations using RPG, it is a risk to have so much of your investment connected to a platform that you basically do not control. So the idea is to find a way to run the code that currently runs exclusively on these IBM machines, run it on the cloud, and also have the possibility to evolve this system using not only RPG, but also other languages. And in particular, we are interested in Java and Kotlin. Now, to solve this problem, SMAP has started different initiatives, but the ones that we are talking about today is Jariko, which is the interpreter that is written in Kotlin, runs on the Java virtual machine, and can execute RPG code. This interpreter is open source. You can go on GitHub and find it. Now, why we decided to write an interpreter? We decided to write an interpreter because we want to save, first of all, the huge investments that has been done in writing this RPG code base. In this case, we have both a core that was developed by SMAP along decades, but we also have a lot of customization that have been built for the different clients and that fit perfectly their needs. So we have no intention to just throw away this huge investment and start from scratch. That would be simply crazy. Also, we have many consultants that know how to use RPG. Now, you have to think of these consultants not as mainly developers, but as someone that can understand the needs of the different customers, can talk with this organization, can translate, find the solutions to their problems and translate them that in RPG code. So they use RPG as a tool, but they're mostly and foremost analysts, and they have their main skill is talk to the clients and provide reasonable solution. We do not want basically to retrain all of them to start becoming Java programmers. They are RPG programs, they will keep using RPG. Also, they are used to edit files on the fly, and work in a live environment. They sit next to the clients present a problem, they immediately present a solution and run it on the live system, on the installation for the client. This way of work is very productive for them because the feedback cycle is very short. They can show someone, the clients can provide feedback, and they can revise very, very quickly. So they do not want to move to a compile and deploy approach. Now, I can understand that developers like me tend to think that this is risky, that we would prefer to compile, run 1,000 tests, then run more tests, then check again, and then deploy the new version. But this is not the way they work, and this is not the way that is productive for them. So we need to understand their context and take that in account. And this is why we built an interpreter and not a compiler or a transpiler. So our plan is to run RPG code into the Java virtual machine, and we can write programs in Java or Kotlin and be able from those programs to call RPG code. And conversely, we want to be able to call from RPG code programs that we've written in Java and Kotlin. In this way, we can get a system where the business logic is written by consultants in RPG. They know RPG, they know how to use it, they have a tons of library for solving the business problem, and they're okay with it. However, the core of the system that needs to support new technologies, maybe new interfaces, and it's written by professional developers, people that as the first skill, the ability of writing code, well, they prefer to use Java and Kotlin, but they want to do that incrementally. So we want the core written in RPG to keep working as it is, just on the new platform. But we want also to give the possibility to add new features writing code in Java and Kotlin, and over time replace the existing modules in the core with the equivalents rewritten in Java and Kotlin when it makes sense, maybe when there is some refactoring or new functionality to introduce in that module. In other words, this is the pattern we are going to support. We are going to interpret RPG code, and when we find a call to an RPG program, we will perform what we internally call doping. We can capture this call, and instead of calling a RPG program, we can instead execute a program running on the JVM. In this case, for example, we are executing this class written in Kotlin, and you can see that we specify a mapping so that the values that are RPG values are automatically translated to values that are specific of Kotlin, and the Kotlin code can be executed, can produce potentially a result that is returned to the RPG code that can continue the execution. Conversely, we have the possibility of taking RPG code and execute it inside other Java programs or Kotlin programs. In this case, we are in the context of a test, so we specify the code as a string literal of 4 lines, but in practice, of course, we want to read RPG code from files because it just makes much more sense. In this case, we just take the code, analyze it, and obtain a program that we can run. We do that on the fly, and then we execute it. And in the end, we check that this program has produced, in particular, this string hello world. And so our test is completed. This is at a very high level the resulting system. We will have a client performing HTTP requests. They will be served by RPG programs and JVM programs that will interact and call each other, and in the end provide a solution. In this architectural design, we can see some more details just to understand that Jariko is inserted in a larger project. Now, there are just a couple of things that I want to underline. in this case, you can see that in the existing system, they have the logic written in RPG, but they have also have this code written in a language they develop internally that specify screens, so specify how to draw the application on the screen, where to put fields and strings and labels and so on. The current application in a console-based application. Now, they have written an interpreter that can read the existing definition and draw a web application. This, combined with Jariko, permits to have a complete web application running on the browser. So the UI provided by them and the logic provided by Jariko. There is also a mechanism to provide interaction with a database that for the moment is still on the IBM AS400. Now, just to see an example, this is an example of a web application that is derived from one of the screen definition originally intended to write console application. This very simple application permits to insert a value, press a button, and calculate the Fibonacci number corresponding to that value. Now, I forgot this slide. Now, when we press the button, we call a routine written in RPG. Now, this is part of a larger program. Here we see just a snippet, but we see the actual RPG code that takes the result from the fib routine and combine it to obtain the string that is then presented here. So, a web application running RPG code. This is all good, but how can we implement this stuff? Well, in general, to implement an interpreter, we need to do two different things. First of all, we need to understand the RPG code. The RPG code is basically a large string. So we need to make sense of it, to recognize the different components, to understand their role, and to build an internal model of this information. Once we have understood what the RPG code is telling us, we just need to execute this. So we understood that this code contains these statements. Now I just need to execute each statement. So at a high level, these are the two things that we need to do. Understanding the RPG code per se is not trivial, of course. And so it's a problem that we split in several sub-problems, so divide et impera, right? We start from the RPG code, our big string, and we split it into tokens. We can regard tokens as the single words contained in our program. Then we understand the structure that is combining this token, and we build a first hierarchical organization of this information, the parse tree. Now, the parse tree is still a bit low level, very connected to the way the code is written. That is not the way that a programmer understands it. And we will see an example of the difference. At this stage, I just want to say that we further refine the parse tree, elaborate it, and obtain the abstract syntax tree that is much clearer. And at this point, we can work on this abstract syntax tree to interpret it and actually execute what it's telling us. Now, the first step, going from the RPG code to a list of tokens, is demonstrated in this simple test. We have a small snippet of RPG code. We are talking about 4 lines. And we tokenize it and so obtain the list of tokens. The resulting tokens are listed in the gray panel. Basically, we see a list of tokens. For each token, we see the type and the actual content of the token. So we understood that the first token, the DS fix token, is recognized because we have this letter D at column 7. Then we have a name. Then we have an S representing a type. Then we have the toPosition field, which is a bit particular and can have different interpretation in RPG, and so on. We basically get a list of tokens, a flat list of tokens. Now, we then need to parse this. In other words, to take the list of tokens and organize it in a tree. If we consider the same 4 lines that we had before, we obtain the abstract syntax tree that is displayed on the left. I do not expect you to be able to read it. I just want to give you the impression of how complex it can be, the parse tree for just 4 lines. I have then put at the center the subset of the parse tree corresponding to just 1 line, the line that is reported below. We can see the same token that we have seen before, plus some other placeholder for tokens that are basically containing just spaces, so are not meaningful. Now, we can see that this is organized in a hierarchical structure. So we have a node of type R. Let's not dive into that. It contains a node of type statement that contains a dspec, then contains the ds fixed, which is a token, and then another node, ds name, which contains the token name, and so on. So this structure has some levels. Now, we want now to transform the parse tree in the abstract syntax tree. On the left, we can see the abstract syntax tree that is obtained for the whole code, so the 4 lines. While here, we can see the parse tree, the abstract syntax tree obtained for just the line of interest. And you can see that this is simpler, is more meaningful. We are saying that there is a data definition with no fields and no initialization value. We have the name, and we have the type. Basically, we are saying that we are declaring a string of up to 12 characters. Now, we can compare side by side the parse tree and the abstract syntax tree. The abstract syntax tree is obtained by combining the information in the parse tree and reorganizing it by interpreting some information. For example, the toPosition field indicates the length of the string because the fromPosition field has no value. Otherwise, it would have another meaning. So we do this elaboration that a developer typically does by taking a glance at the code because they spend all their life with RPG. But we make this information that is implicitly present in the code, we make it explicit in this abstract syntax tree. Now, the way we implement this tree transformation from RPG code to tokens, from tokens to parse tree, from parse tree to abstract syntax tree is by using a grammar for RPG and for the Untitled parser generator, which is open source and which was written by Ryan Eberly. So a big thank you, Ryan. We, of course, took it, patched it, extended, and changed it as needed, and release it as open source as part of Jariko. But it was really important to really jumpstart the process. Finally, the last step, the parse tree to abstract syntax tree step, was instead implemented by us in Kotlin. So I don't want to go into many details on how to write lexers. Very interesting topic, but there is not the time today. I just want to show you an example of the lexer for RPG to tell you that writing a lexer for a fixed program, fixed format language is complicated because you need to consider at the same time the content of a certain token, but also its position. So for example, the string D, if it appears at column 7, it means that that line is a data specification lines. However, the same token appearing in another position could indicate a name, so a variable named D, for example. So it's a bit tricky. The parser instead is pretty standard, so we are not going to dive into it. Let me just say that Antler 4 is very convenient for writing this kind of parser, so we didn't encounter too many problems there. Now, what is instead a bit more specific of our approach is the definition of the abstract syntax tree. In the abstract syntax tree, we will have node to represent all sorts of concepts present in the RPG code. So we'll have the concept of the entire file, a compilation unit. We will have the concept of a subroutine, a statement, an expression, and so on and so forth. For each concept, we define a data class, which is a very simple way to define structure in Kotlin. It's very convenient, and you can see on the screen the definition of tree structures, nothing fancy here. Then we need to do another thing, that is defining the mapping from the parse tree to the abstract syntax tree, because the abstract syntax tree is obtained by transforming the parse tree. What we do is defining a set of extension methods, so methods that are added to a class outside the definition of the class itself, and we extend the classes of the parse tree that has been generated by Hunter by adding these toast or two AST methods. In this way, I will be able to take every node of the parse tree, call on it the method toast, and obtain the equivalent node of the abstract syntax tree. Now, a lot of information is transformed very simply, very directly. It's a one-to-one mapping. Okay, so we just need to call recursively the toast method for each children of my current node in the parse tree and combining the result to obtain an equivalent node in the abstract syntax tree. However, this is not always the case. Sometimes I do some elaboration in these transformations. For example, from the point of view of the parser, so of the parse tree, there are a lot of identifiers that are just identifiers. There is no reason for the parser to differentiate between them. Instead, we want to differentiate them in the abstract syntax tree because they play a special role and they will need to be interpreted differently. So, for example, if we find the identifier asterisk blank or asterisk blanks, there are two equivalent ways to indicate a blank expression which must be interpreted in a certain way. And so we perform sometimes this transformation not one-to-one, but one-to-many. What in the parse tree was an identifier could become an identifier or something else in the abstract syntax tree. In addition to this, we need all sort of elaboration to simplify our life and make easier to later interpret the code. For example, in RPG, I can define implicitly some variable inside statements. If I'm not mistaken, in the clear statement, I can refer to a variable. If it doesn't exist, I implicitly define it. Now, that's not great. For our needs, it's better to know upfront all the existing variables. So we process the abstract syntax tree, find all the statements that are defining implicitly variable, and we add some explicit definitions that we will use during execution. So that's something important. Another important thing that we do is symbol resolution. Now, in all programming languages, I typically refer to something else. I can have the expression a plus 1, where a is a reference to a variable, a parameter, a field, whatever. When we build the abstract syntax tree, we consider the scoping rules of RPG and figure out that a in this context refers to the variable a, while a in this other context refers to a parameter a. And so we add a link from the usage of a symbol to the declaration of this symbol. And why this is useful? It's useful for many reasons, but one, for example, is to understand the type of a symbol. If I have the expression a plus b, depending on the type of a and b, this could be a string concatenation or an arithmetic sum, right? If a and b are two integer variables, I want to sum them. If they're two string, I want to concatenate them. Wonderful. But if I look at A and B, they are just names, so I don't know what they are. I need to find a corresponding declaration, and the declaration will tell me this is a string, this is a number, so you want to treat them accordingly. Same is true for example, subroutine and function calls. Well, this is not true for programs because we want to resolve them at runtime. In this way, we can have this mechanism substituting RPG programs with Java programs. Okay, now this was the first step. So understanding the code, we have this abstract syntax tree that is derived from the code and obtained through further elaboration and processing of information. Now we need to actually execute this code. To execute this code, we basically go through every statement, and depending on the content of the statement, we do something that could be producing a side effect, like printing something on the screen, or instead changing a value in the symbol table. In many statements, I will need to evaluate expressions. Basically, we will need to do that for every statement. And we could need to evaluate expression to access values from the symbol table. So this is something very important. Now, at its core, an interpreter is basically a big switch, right? So we look at the kind of statements, and depending on the kind of statement, we do something different. In this case, we have the first example, the execute subroutine statement. We do some logging, we do some performance tracking, but then the really important thing that we do is this line, which is highlighted. In this case, the statement contains a reference to a subroutine. Given we have resolved the symbol, we know which subroutine it is. So refer is a link, a pointer to the definition of this subroutine. And given we have a pointer to the definition of the subroutine, we can access the list of statements that are defined in the subroutine that we want to invoke. And so we can execute them immediately. Subroutines do not take parameters, so we do not need to change the symbol table, pass parameters, nothing of that sort. Subroutines communicate with each other through global variables, so it's just okay to take the list of statements and start executing them one by one. So the interpreter we have seen that contains at its core a big switch that, depending on the type of statements we recognize, does something. It then contains also another very important switch, that is the switch that we use to interpret expression. Also in this case, we look at the type of expression, and depending on the type of the expression, we do something different to calculate the value. Now, many expressions are trivial, literals in particular are very trivial. If I have the literal, the string foo, the corresponding value is the string foo. Like if I have the literal 3, the corresponding value is 3. While other expression requires more elaboration. We can have data references. For example, a plus 1. In the expression a plus 1, a is a data reference. So basically, I need to go on the symbol table, read the current value of a, and the current value of a will be the result of this expression. Then we can have, for example, a quality expression. In this case, we evaluate the value on the left, evaluate the value on the right, and then we verify if they are equals according to the definition of equal that we have in RPG that could include some conversion and so on. Now, regarding the symbol table, at its core, a symbol table is substantially a map. So basically, we have some entry that is a symbol and a corresponding value. Sometimes I can assign a value to the variable a and write, I don't know, 3 in the symbol table. Later, if I'm using the variable a, I go on the symbol table and read the same value. So at its core, this is a map. However, there are other things that we need to do in the specific case of RPG. Let me name 2 things, which is projected array and coercion. Let's start with coercion because it's simpler. Depending on the context in which I use a certain symbol, I may want to automatically convert it from an integer to a string or vice versa, typically. Or maybe if I use it in a place where only a shorter string fit, maybe I need to cut the string. So I need to do this kind of operation and so adapt the value to the place where it will be used. Another concept that is instead specific of RPG is the concept of projected array. I hope that I'm explaining it correctly. If not, maybe some RPG expert will correct me. But basically, we can have data structures like the AR01 data structure, which are array, and they can contain different fields. So I have an array of data structure with different fields. Among them, I have the field Phi07. Now, in RPG, I can treat Fe07 as it was an array. So instead of saying, I don't know, take the element 10 of the array of data structure and then access the field, I can directly pretend that the fields are also an array and say, I don't know, Fe0710, that means take the 10 instance of the containing data structures and then the field. Now, we made this transparent by adding some code in the symbol table. So this is just an example of the peculiarities that you may have to deal with when dealing with different languages. Now, I think we are running out of time. If I'm not mistaken, we have time. We have another 5 minutes, so I will see what I can describe of this. Otherwise, we can deal with this during the discussion. But these are random things that are vaguely interesting about this project. For example, this is the mechanism that we use for the interaction between RPG and Java. The Jariko is a library written in Kotlin, so I can use it in Kotlin or Java programs, Scala, Clojure programs, and so on. Now, when I want to mix some Java programs inside my RPG programs, I do that by, first of all, preparing a registry. And for example, registering that I want to associate a certain Java program to the name JDURL. Then, once I prepare my registry, I start the interpreter, and my interpreter starts running, will execute some RPG code, execute each statement. When it reaches a statement that contains an invocation of a program, it stops. It checks in the registry if there is a map Java programs associated to the name. If there is, it will execute this Java program, wait for it to finish, take the results, and continue the execution of RPG programs. If there is not a Java program overriding RPG programs, it will simply look for an RPG file with that name and execute it. So that's the way we manage to make them interact. Now, a very interesting topic that would deserve a lot of time that we do not have right now is the integration of the runtime. Now, this is a work that has been performed as SMEAP, so they know the details of it better than me. But basically, you have to consider that when I'm running RPG programs, they of course expect to find all the functionalities of the platform for which they've been created. Including in those functionalities, there is access to a database that use the indexed sequential access method paradigm. This is something that I start to understand, but it's quite peculiar. Basically, I perform certain search and I move in a way the cursor at a certain position on my file, and then I can use instruction to move forward or backward. So this is a paradigm completely different from relational database and SQL. But they have done a great job because they managed to find a way to translate this call based on this paradigm into SQL call behind the scene. In this way, it's now possible to have RPG programs that expect to find a database working with this paradigm that behind the scene are calling instead any database support by JDBC. So I think this is a great achievement. We have built support for unit testing. They've built a nice integration with Visual Studio Code that provide a much more modern paradigm. Let me just say this. This is the first concrete application that I have built consisted in a system that read the plates of people approaching the gates, check if these plates are associated with employees at the company, and if so, they open the gate. Part of this system is written in RPG, the one that check if the plate is associated with an employee, and part has been written in Java, the part that control the gate. So I think this is a very interesting thing. I have links, but I will skip it. There is a page where it would be possible to play with it. A lot of future work, but I think we are running out of time. So I want just to thank you, say that I'm Federico from Strumenta, and Strumenta is Latin for tools or Werkzeuge, if I pronounce that correctly. And basically our goal is to provide tools to help people, to help professionals work better, and we do that by creating parser, compilers, interpreters, and editors like we've done in this case. So you can learn more about this project. It's open source, go on GitHub, learn more. And if you want to learn more about Strumenta and this stuff, I have a technical blog with a lot of free articles. So thank you and sorry for being 1 minute late.